Okay, so here's the procedure for factoring out the GCF, our first factoring method. Now, as I talk through this procedure, I'm going to do a baby example to help you sort of put it together in your mind. So we're going to work with the fairly simple polynomial 2x plus 6 as we talk through this procedure. So first, if you're factoring out the GCF, you have to find the GCF between all the terms in the polynomial. So if you look at 2x plus 6, these are your two terms. Right? Your first term, your second term. So you have to find the greatest common factor between 2x and 6. Well, in the first term you have a 2 and an x. In the second term you have a 6, which is 2 times 3. So the GCF between these two terms is going to be 2. Right? They both have a 2 in them and nothing bigger. Step 2, rewrite each term as a product with the GCF as one of the factors. So step 2 says I'm going to take my original polynomial and I'm going to rewrite each term with the GCF as one of the factors. So 2x I can think of as 2 times x, that's what 2x means. And then I have to rewrite 6 with a 2 in it, so I'd have to rewrite the 6 as 2 times 3. Now step 3 says pull the GCF outside of a pair of parentheses by reverse distributing. So in step 3 you take this new form of your polynomial, 2 times x plus 2 times 3, and you reverse distribute. Right? You pull the GCF outside of a pair of parentheses. So this is the GCF. It's sitting in both terms. You pull it outside of a pair of parentheses, so you put 2 parentheses. And then you think, well, what would you have to write inside the parentheses to get back to 2x plus 2 times 3? Well, you've already pulled the 2 out, so that's taken care of, and what you have to write inside the parentheses is what's left over. And so now we've factored this polynomial because we wrote a product. It's 2 times x plus 3. So that's the procedure to factor out the GCF, and we have plenty more examples down below, don't worry. Okay, so in example 2, we actually get to start factoring. Okay, the instructions say factor out the GCF for each polynomial. So we're going to practice our first factoring procedure. In order to factor out the GCF from a given polynomial, you have to first identify the GCF. Okay. So we're going to look at each of the terms, 6m squared and 15m, and determine the largest factor that they have in common. For the coefficients, we're going to have to factor them down. 6 is 2 times 3, and 15 is 5 times 3. So the GCF for the coefficients is just 3, because that's the biggest factor they have in common. So my GCF is going to have a 3 in it. But now I need to consider the m's. Okay. So this guy has an m squared, and this guy has an m. In common, you have to take the one with the smaller exponent. They have an m in common. Right? M squared has an m in it, and m has an m in it. So the GCF must have an m in it. So the GCF for this polynomial is 3m. Next, our second step is to take the original polynomial and rewrite each term using the GCF. So for example, I want to take 6m squared and I want to write it as a product of the GCF and some other monomial. And I want to take 15m and write it as a product of the GCF and some other monomial. All right, so the question is, what do I have to put after these multiplication signs? So what do I have to multiply 3m by to get 6m squared back? Well, 3 times what equals 6? 2, right? So I'm going to put a 2 here. 3 times 2 equals 6. M times what equals m squared? M times m equals m squared. So I need to multiply 3m by 2m in order to get 6m squared back. So 3m times 2m will give me 6m squared back. And then for the 15m, I go through a similar thought process. What do I multiply 3 by to get 15? Well, I need 5. What do I multiply m by to get m? Well, I don't have to multiply it by anything. I already have it. So then I have my 15m back. So for my third step, I have to reverse distribute. So I take my new form of the polynomial where the GCF is sitting in each term, and I reverse distribute. I pull the GCF outside a pair of parentheses. So I'm going to pull this out. So I have a 3m, and then I write what must be left. If I take the 3m out of the first term here, I have a 2m left. And if I take the 3m out of the second term, I have a plus 5. So this is my factored form because I've written my polynomial as a product. Right? I have a 3m times the polynomial 2m plus 5. Alright, so for part B of this example, we have a slightly more complicated polynomial to deal with. All right, we're given 36p to the 6th q plus 45p to the 5th q to the 4th plus 81p to the 3rd q squared. The procedure is still the same. First, we have to figure out the GCF. Okay, so to find the GCF, I'm going to go ahead and factor down all the coefficients. Right, so 36 is 6 times 6, 3 times 2, 3 times 2, etc. Once we have the coefficients factored, we have to look for the biggest common factor. So we see in all of the numbers there's 2 3s and that's it. Right? The 36 has 2 2s, but the 45 doesn't have a 2. The 45 has a 5, but the 81 doesn't have a 5. Right, so there's nothing else in common, which means as far as the coefficients are concerned, the GCF must contain a 9 in it, right? 3 times 3. Then we go on and we consider the variables. P to the 6th, P to the 5th, P to the 3rd, what do they all have in common? The lowest variable, right? So P to the 3rd. And then as far as the other variable, the q goes, we have a q to the 1st, q to the 4th, q squared. So q to the 1st is the variable with the lowest exponent, so that's the one we're going to take. So the GCF is 9p cubed, q to the 1st. So then for step 2, we take our original polynomial and rewrite each term using the GCF. Okay, so I've rewritten the original polynomial, and then underneath I've wrote the GCF times blank. Basically, we have to fill in the blank for each term. Right, so 36p to the 6th q should be written as 9p to the 3rd q times something. So what do you have to multiply 9 by to get 36? That's your first question. Well, 4. And what do you multiply p cubed by to get p to the 6th? P cubed again, right? Because when you multiply p cubed times p cubed, you add the exponents and get p to the 6th. What do you multiply q by to get q? Well, 1, but we don't even need to write that 1. So this is all we need. In the next term, what do you multiply 9 by to get 45? 5. What do you multiply p cubed by to get p to the 5th? P squared. right? Because p cubed times p squared is p to the 5th. You add the exponents. What do you multiply q by to get q to the 4th? Q cubed. Then on to the last term, what do you multiply 9 by to get 81? 9. What do you multiply p cubed by to get p cubed? 1. Okay, but we won't even write the 1. What do you multiply q by to get q squared? Q times q is q squared. Finally, we're ready to move on to the last step of our factoring procedure, which says we have to reverse distribute, okay, pulling the GCF outside a pair of parentheses. Right, so let's rewrite the polynomial in its new form and then reverse distribute. So there's my polynomial, and then in each term I've already written the GCF, so this is what needs to get pulled outside a pair of parentheses. So we're going to pull out the 9p cubed q. And then inside a pair of parentheses, we're going to write what we have left over, what polynomial we would need to put here in order to get us back to this unfactored form. So if you take out a 9p cubed q, you're going to have 4p cubed left from the first term. You're going to have a 5p squared q cubed left, and a plus from this plus sign. In the second term, and then in the third term, you have a 9q left. So this is the factored form of our polynomial because we've written this polynomial as a product of two other polynomials.